So let us talk about a problem, trailing zeros in a factorial. So basically we have been given a factorial number which is n, and in that factorial of n we have to find out how many zeros will be occurring. So basically if you look to this problem in this way, that basically if you look to this problem in this way, so we have been given trailing zeros we have been given as trailing zeros in a factorial. So let's understand this problem carefully. So suppose we have a number, let's say 5. So 5 is our n, and we have to find out number of zeros in 5 factorial, the n factorial. So 5 factorial, as we know, it's like 20. So factorial of a number is basically multiplication of all the numbers from 1 to the number. So basically like from 1 to 2 into 3 into 4 into 5 till the n, 1 to n. Okay, so here we all know that we have a 0, so count of 0 equal to 1. Right now for our understanding we can see directly that there is only 1 0. So how do we approach this question? Like, what should be the general approach? So first approach is basically either we can directly convert this number into separate digits and count out the zeros like separately, like if we take 1 as separate number, 2 as separate number, and 0 as separate number. So we can compare each. Is 1 equal to 0, then not. If it is not, then don't update the count. If 2 is equal to 0, is it 0? No. So we are not updating the count. Is 0 equal to 0? Yeah, it is equal to 0. So we are updating the count as +1. So if we go through this problem, we can apply this thing as one solution. So what should be the general code for this? And like first we'll see two approaches. There are two approaches for this question. Like one will be the efficient approach and the second will be the inefficient approach basically. So we'll look that we have been given the time complexity as O of log n. So we should optimize the code for this time complexity. So let's see the both possible solutions. The first solution says, so by first solution we can say like splitting the number into separate digits and then counting the zeros, which is pretty simple. So if we write int, so let's take a function directly, count zeros in n. So we are taking a function count zeros, which is counting the zeros present in n factorial. So here we need to calculate our here we need to calculate our n factorial first. Then we need to calculate the zeros in n factorial. So let's calculate the factorial. Int fact equal to 1. Initialize the factorial as 1. So factorial for we can take as, so factorial is already 1. So we can take the I value from 2 to n and increment it every iteration and multiply. Basically factorial is multiplication. So for I, int I barabar 2 will move to I less than equal to n, and then we'll increment the I. So once we do this, we need to perform the multiplication fact equal to fact into I. So this is the basic solution like for calculating the factorial. So now we need to find out the zeros. So for zeros, we'll initialize a count, int count equal to 0. So while fact mod 10 equal to 0. So what does this fact mod, like mod does actually. What does this fact mod does actually? So if you look carefully, fact mod 10 basically gives us the remainder after dividing factorial by 10. So if we suppose we have 123, so 123 mod 10, what it will do is it will take 12 as quotient and 3 as our remainder. So this should be equal to 3. That's the basic thing. Then we have second thing, as we need to update the result, the count, sorry. We need to update the count plus plus. Then we need to divide the factorial by 10 again, because we have scanned one number. After scanning this number, if it is equal to 3, then update the count. If it is not equal to 3, then delete this number and check for rest of the remaining. So first we'll do this equal to fact by 10. So this is done, and return count. So if you look carefully, this question basically, yeah. So this solution, this code isn't actually efficient. Why isn't it efficient? Because in the first half of the question, we are simply calculating the factorial, like wasting time. We are wasting time over here. And if you look carefully as well, the complexity of this is something like in the order of n. It's something in the order of n. Time complexity is in the order of n, which is not that what we want actually. So we want log n. We want this. So why isn't it efficient? Because if our number becomes too much huge, so there is a chance of overflow. So we can't handle this much quantity of number, this much size of number, which leads to overflow. So for big numbers, this code really becomes inefficient. So what is the next thing which we have to do? So the next thing which we have to do is, so let's take 5 factorial. So suppose we'll take 720 or something, a large factorial. Suppose you take 10 factorial, okay? So for 10 factorial, so 10 factorial will have 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 and into 10. So if we look a pattern here, so we have every fifth position as multiple of 5. Every fifth position is multiple of 5. So if you go from here 5 positions, this is even multiple of 5, 2 into 5, yeah. Then supposingly we move to 15, supposingly we move to 20, supposingly 25. Even after 125, we'll get a 5. It is every fifth. How many 5s? We don't know how many 5s right now. So, but after every fifth location, we are going to get a fifth 5's multiple. So what we can say? So till 25, like till the multiple of 5, like it is 5 square, which means that 2 times 5 has came. So 5 is just once here. So till this just 25, till the 25, we are only having one 5's multiple. Once we cross 25, we are having 2 multiples, like 2 5's in the number, 2 5's in the factorial of that number. Once we cross 125, we are having 3, 125 or 125 plus. So suppose if I have to look for factorial of 127 factorial, I'll just go after this, right? I'll just go after this. I'll say that I have 3 multiples of 5 in that numbers after 125. So I can get the zeros easily. So here 1 0 I am getting, here another 0 I'm getting. So here if this is multiplied with something else, we are getting one more 0. Accordingly, we can create a floor function. We can create a floor function which says for this condition, it says n by 5, n by 5, then plus n by 25. It says basically till n equal to, like, till this 25, how many 5 multiples have came. Based on that, we are going to decide our zeros. So plus n by 125. So this is the thing. This is the main crux of this problem. So if we write this for this thing in a problem, like this thing in a code, so we are going to get, we can write it directly that, like, so we can write a function int count zeros int n. Okay, so we are having the function as, so we'll take a result, int result barabar 0. So right now we are assigning it to 0. Then for I, int I equal to 5. We are beginning with 5. That's it. We are beginning with 5. I less than equal to n. Then we are incrementing the number with the 5's multiple. So after this, we are directly going to 25. We are directly going to 125 because we need the multiples of 5, nothing else. So we have to do I equal to I into 5. Then we are adding the loop for result barabar, sorry, we took it as res, right? So res barabar res plus n by I. या हम इसको बाद में जाके ट्रेस भी करेंगे, just wait for it. And once this is done, then we are returning res. Yeah, so let's कुछ लोगों को ये समझ में नहीं आया होगा, like, because they might not know what this floor function is doing. So let's take a problem n equal to 251. Okay, so we are taking n equal to 251. So our number is 251. So 251 ka factorial, if you see, it is too much large. Like, it's like how many zeros it will have, we can't even imagine. So let's take the result res equal to 0. At start we initialize this point. So res equal to 0. Then first iteration is I equal to 5. Okay, so res equal to res plus, so we divide this by I. So we have I as 50, 251 by 5. Yeah, so we'll get this around 50 exactly. And res, so res is 0, so res right now becomes 50. So second iteration I equals to 5 into 5, which means I is 25. Then we have res equal to res plus 251 by 25. So what does res is? This is 10 plus 50, which comes out to be 60. Then we have third iteration. We have 125. Then I barabar 125 will have. Then we have res equals to res plus 125 by 251 by 125. So we have res as 60 plus 2, 62. So our answer should be 62. That's very simple, right? So that's what we are doing. So let's code this out. Let's code this out. Let's go to this window and code this out. So first we are assigning result. So first we are assigning result, which is res. So let's code it out. Assign int res equal to 0. Then we are moving for loop for int I equal to 5. Then we have I less than equal to 5. Then we have I equal to I into 5. Yeah. So next is our result updation. So we'll update the result in a way like res equal to res plus n by I. So let's complete and return the res. Yeah, so it's pretty simple. Let's run this out. Okay. There is a mistake. Equal to n. Yeah. Now it should work. Yeah. See, we got the output. So let's submit this. Yep, it passed the test cases. And make sure you like this approach. Like every time you try to fix in this time complexity which they have given. So in almost every contest they will be doing the same, and even in the company interviews and all placements and all, they will be asking us to fix it in a simplest way, the most efficient way. Yeah, so that's all for this problem, and thank you.